Hello and welcome to Inventor Basics, a series of videos where we can look through Inventor, starting from the basic modelling through to more advanced in the end, just to help people who are trying to learn and have never used the software before, show the basic sketching, the basic modelling, the basic features to get them started. In the last episode we looked at extrude, the cut and extrude, the hole feature, the fillet feature and the chamfer feature. In this episode we are going to look at some sketch constraints, briefly go through them, the Revolve, the Loft and the sweep feature. We'll look through them, starting off with the sketch constraints, just to get a basic knowledge of the sketch constraints. So we'll start a sketch. The sketch constraints constrain the lines and the sketches that we draw. As we've seen before from down here, we want our model always to be fully constrained. So if we start off with the coincident constraint, so if we draw a line, we can dimension this line to 20. Now if we draw another line, we can start from here and go along. Now if I draw this line and I'll dimension this to 20. Now if I press F8, this will show my constraints. It shows a horizontal and a vertical. Now if I delete this line I've just drew, I could also use this constraint, as you can see from the little picture. If I select this point and then select this point, that also creates the coincident constraint. It creates it for free when you draw it on it, but sometimes you can draw the line to show, in this example, that is the constraint, as we can see there, that joins them two lines together. So that's the coincident. Right, let's delete that. The next is the collinear, which if we draw, we'll draw a line 20. Now if we draw another line at 20, we'll draw it straight. Now the collinear will make this line in the same line as this line. So if I select this line, it puts it in line. That's what the collinear constraint does, and this won't move. You can move side to side because we haven't dimensioned it. If I dimension the distance to 20, we're fully constrained, and no, it won't move. So that's what the collinear, and you can see there from the F8. F9 will get rid of the constraints, but if you ever want to see what constraints F8, we can see horizontal because the line is horizontal, and collinear as a line are next to each other like that. Now the concentric. Now the concentric is used for circles. So if I do 50, then draw another circle at 40. As you can see from the photo, a concentric will place this circle concentric to this circle. Fully constrained because both of the circles are dimensioned. If we press F8, we can see the concentric. All of these can also be done if I pick the center point of the circle 40, you can do it that way, but I'm just showing what the concentric constraint will do. The next one is fix. Now this one is used, there's no dimension on this. As you can see, there's 3 dimensions needed. But if I click the fix and then just click on a line or a circle or a square, as you can see at the bottom, 3 dimensions, click on it, it just fully constrains it. No dimensions, it will just totally fully constrain it. You can dimension it, which is better than, so now if I fix it, I have got the dimension. Oh, but it won't, it's added over constraints. You can over constrain a sketch as well. When there's too many constraints, it won't let you add constraints. Even though we need 2 more dimensions, it won't let us add that constraint. So if we now have to constrain it correctly, let's find the center point. Now we can take the center, put it on the center, fully constrained. So that's the fix, and the fix will also work with a line. If you drew a line, if you drew 2 lines, click the fix, 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 and now they're fully constrained. And then all we have to do is constrain them to a point. Oh, there's a constraint missing somewhere. Oh, the length. So if we do the lengths, now that's fully constrained. So the fix won't always fully constrain. In that is an example where you still need to dimension the lengths of these. I don't really use it that much, but it can be used. Now the next is parallel. So an example for this would be if we had a line projects like that, fully constrained, and if we did a line at a different angle, like that for example. Now the parallel will make this line parallel with this line. So if I select this, select that, that line is now parallel. To fully dimension, we can put a distance in between, and then we can just dimension from that end to that point, the start of that, put a 0. Now that's fully constrained. So the parallel just places the line you select parallel with the line that you've already drew. That will possibly be constrained. And the next is perpendicular. So if we draw a line of 50, what I'm doing here is, you've probably seen me do it and perhaps you don't understand what I'm doing, is projecting. So I'm projecting the center point of our origin onto this sketch. So if I select that center point, you can see a little purple dot that now projects that center point through to the sketch, so I can use that center point. So now I will use a coincident, pick that point and place it onto that point. As we see, the little orange square, that means a coincident, which will bring the F8 up and we select it. And this here, this box with like a plane above it, that's the projected geometry, as you can see, showing that it's projected that shape, which is the square, through to the plane that we're drawing on, or sketching on. Right, so a perpendicular will create, as you can see in the photo, we can make this line perpendicular to that, but that line straight anyway. If I did a line like that, it will make it perpendicular to any line. So basically, if we just put that onto there, we can dimension it to 50, delete that. So this is fully constrained. So it puts right angles perpendicular. So that's a right angle, that's a right angle. So that's what perpendicular, any line you place the perpendicular constraint to, it creates right angles either side. The next is horizontal, quite a basic one. Literally, if you have a line that you've drew at an angle, click on the horizontal constraint. As you can see, the dotted line going across horizontally, select the line, horizontal line. That one's pretty simple. Same with vertical. If I drew a line like that at an angle, not vertical, select on vertical, select the line. You can see dotted line going down, it creates it as vertical. One thing with this I would say is be careful, because you can select the center point of the line and it will do nothing because you've selected the center point. So you need to select the actual line, and then that's the vertical. The next constraint is the tangent. So if I constrain this dimension, now if I draw a circle, the tangent constraint will just make this circle tangential to the line, just like that. So now this is tangential to this line, as you can see. Right. Smooth. This is very rarely use this constraint. An example to show: if we drew a spline, we haven't drew splines yet. This is just to show an example, and then just draw a straight line. That's not smooth. The transition between the spline to line isn't smooth. So if we select our smooth command, select the line, select the curve, it creates it as a smooth transition. I mean, I don't think I've ever used it, but possibly, but that's an example of how that works. And the next is symmetry. An example would be, dimension this up. If we had a line here that was a set distance from this line, 25 will do. Then if we had a line, another way to use the horizontal actually, which I'm going to use now to show you while we're doing it, is if I select the bottom point of this line and then the bottom point of this line, it puts them points horizontally, which is very handy. So now we have 25 here and 44, 45 there. The symmetrical will allow us to select these two, select the middle, and then that will make this distance 25. Pretty simple, comes in handy. The next constraint is equals. So the best way to show this would be to have a circle at 50. Just constrain that. Now if we drew another circle any size, we'll make it smaller to show. The equal sign will take the dimension from this circle and then place it onto that circle without having to dimension it. So this is now 50, as we can see. So that's what the equal sign does. It will just take, if you've dimensioned a line or a circle, it will take that dimension and apply it to another one. But as we can see again, adding this dimension will over constrain the sketch. That's because the constraint, it knows it's 50. Because we've used the equal sign, it knows the diameter is 50. We're not going to be able to dimension it because it's not needed. You know, if we wanted to, we could just to fully constrain it the same again. You could use the horizontal or vertical to get the points lined up. And then if we dimension a distance as 60, fully constrained. So now we will look at the sweep command. Now for the sweep command, we need a profile and then a path for the sweep to follow. So we will do a circle, diameter of 40, fully constrained as we can see, which we want. Finish the sketch. Now these here, let's turn these planes on so you can see. We need to create a path that starts at the center of this circle and then comes out for the profile to follow. So we need to select a plane to draw that path on, which we could use the YZ or the XZ because it will bring it out this way to create the path. We will use the, depending on which way, if I wanted it to go horizontally, I would choose the XZ. Vertically, I would choose the YZ. We'll choose the XZ for this example. Now, I will use the projected geometry, even though we probably could select the center point, but I will use the projected geometry to project the center point. Because we can use this, if you get confused what plane or how to get to that, back to that view, you can click that and then look at the plane and it will bring you back. Now, because we projected the geometry, it will turn green when we select the center point. We'll just draw a path. Now this is the path that this profile will follow to sweep along. So what we need to do now is dimension to fully constrain it. Now we're fully constrained, and if we press F8 we can see the constraints that's been used over it. There we go. Finish the sketch. Right, now if you want to turn the planes off, you can turn the planes off to make it look more clearer. Now sweep. Because there's only one profile, it will automatically select that profile. Now we have path here. Simply select that path, and then as we can see, it creates the sweep. And that's how you do a sweep. Pretty simple, pretty basic. Right, let's start afresh. The next we will look at is Revolve. Select the plane. We'll do a rectangle. We'll revolve a rectangle around an axis. So use the horizontal, find the center point of the sketch, dimension 20, 125. Now we need to dimension, because our axis will go down the center, we need to dimension. You can either pick this line or the center. I'll pick the center, so I pick the center of the rectangle, so the center point, and this will allow us to dimension. So if we dimensioned 150, fully constrained. Now here is where our axis will be to revolve around. That's why we've dimensioned from that center point. So now in the origin we've been looking at planes, but if you see also we have axis. So if we find the axis that we can revolve around, which will be the Y, make that visible, and then revolve, automatically select the profile because there's only one axis here, pick the axis we just made visible, and then we have it revolve. There is an option to do two in between, but we have nothing to go to in between. You can use planes, but at the moment we don't have that. Just simply we want to show the full or an angle, so you could have 90 degrees, or we will do 180. So now that revolves around that profile revolves around this axis 180, and that's the result. That's the revolve. Pretty basic again. The next is Loft. We'll do a square to round. So we pick the center point. It's gone green. That means it's going to constrain. Dimension. We'll do 200. I want to do 200 again. So if you remember, I'll just select the dimension, which will automatically do that. Fully constrained. Now I'm going to make this plane visible that we drew on. With the Loft, we need a plane offset from this plane to draw the circle on to loft between. We haven't really looked at planes yet, but we'll look at offset. This is just to create new planes. to sketch on. You can sketch on a face or a plane, but this is creating new planes. So this is offset from plane. So this will allow us to select the plane we're sketching on, and then select an offset distance. So if we place 150, we can now see we have created a new plane which is offset 150 from the original plane we sketched on. And this is used to now create our circle to create a loft. So if we start sketch on this plane, select the center point, we'll place it at 150, fully constrained. We can see there, these are the two profiles we'll loft between. So simply go into loft command, click to add, select the square, click to add for the second section, click the circle, and then I'll just delete these, I'll turn the visibility of these off. And that is then our loft. The loft between the circle and the square. Pretty simple again, but if you don't know how to do it, sometimes it can be awkward. And that's it for this video. Hope it's helped people. I'm trying to think of good content, start from the basics, going through, because if it seems easy, but if you don't know what you're doing, it's not that easy. And I hope to see you all